Hi, thanks for coming along. My name's Lyndsay Prewer. I'm an independent Agile Delivery Consultant. I'm currently working with Equal Experts at HMRC Digital, where we've got over 30 teams who are deploying multiple times a day into production. This session is an experience report where I'll be sharing some of the best practices and pain points that I've observed in two very, very different cultures over the last few years. As this is one of the last talks of the day, and people have been learning about continuous delivery all day, I thought it might be a bit of a challenge to keep talking about continuous delivery. So I thought I'd pick another topic or use a metaphor for continuous delivery, which is donuts. Hands up here if you like donuts. Great. Okay, so donuts will feature several times in the talk. But as an experiment, we'll just start off with some donuts now. This is in no way to increase the ratings, by the way. This is so if you like a donut, help one and pass the box along. So this session is looking at an organization that is using Scala microservices to deploy services into production. And we're comparing that with another team which has a .Net monolith that also deploys into production regularly. So both teams are doing continuous delivery really well. They're deploying into production at least once a week. We'll be looking at what things have helped these teams get better at continuous delivery, what things have helped them go faster, both what things are shared and common to their different cultures, and also what things are unique to their different culture, unique to their own cultures. We'll also look at the pain points. So what are the things that have slowed these teams down, both common to both cultures and also particular to either a monolith .NET culture or a Scala microservices culture. So back to donuts, just to try and keep your attention. So if we think about continuous delivery in terms of donuts, which is easier for some people to get their heads around, the aim of continuous delivery is to try and take some raw ingredients and get them to a happy customer as quickly as possible. According to the internet, this is Krispy Kreme as well, they can take raw ingredients, produce a donut in about 2 hours. Doing a continuous delivery with such a short cycle time gives us fast feedback. So we know very quickly whether we've made a change that has made customers happy, or it's a change they haven't noticed, or it's something that's made them sad. The other aim of continuous delivery is to try and reduce risk. We're trying to reduce the smallest change into production as frequently as possible. Just like with these donuts here. If we get one donut out to a person and they don't like it, we can quickly adapt how we're working and improve the way we're making things. It also doesn't waste very much. Donuts will come back later in today's session, you'll be pleased to hear. One of the things that inspired this session was when I was looking at different continuous delivery cultures and places that do it well. And I realized that having worked for a number of years in a place that has been doing weekly deployments to production with a .NET monolith, and now in my current place where we've got Scala microservices, there's no single recipe that says, this is the architecture you use, these are the practices you must follow, and this is the culture that is perfect for continuous delivery. I think this is further evident when you compare some of the leading giants in the IT world that do continuous delivery, such as Etsy and Netflix. They both have significant sizes of applications, they both do a significant number of deployments, and they both have quite a massive amount of traffic hitting their services. But very, very different in their culture and also in their stack. So now I'll look at a bit of context about each of the places. So the .NET monolith place is a private sector organization that's funded by a range of private investment. It's been going for about 15 years. It started off very small by a few people, and it grew from I think it was classic ASP and some VB scripts plus MySQL running on some servers in someone's loft, to a multinational company that has massive amounts of traffic. Over that 15-year period, some of their code has lived on. So they have significant legacy code. For the last 5 years, they've been using lots of best practices and trying to reduce the legacy code, but it still permeates different parts of the system. When I was there were about 2 product teams, and over the last 2 or 3 years, they've grown to 8 product teams, so a fairly sizable development organization. I think one of the things that impressed me most and helped inspire this session was that just as I joined, they'd successfully made their transition from doing deployments once a year to once a week. And it was a huge undertaking. And some of the best practices that we'll talk about are things that enabled them to make that switch from yearly to weekly releases, and also help them to continue with weekly releases and make them easier. A bit of detail about their architecture. So, as is popular in most places now, they're a cloud-based company. Even when they had their own servers running in someone's loft, they called themselves a cloud-based company, but now they're using things like Amazon, so truly cloud. They've got three monoliths, to be honest. So a big C++ donut, something similar size that's in C#, and then they have a MySQL database that is often described as a big ball of mud. And that's probably one of the most constraining parts of this system. The traffic that they have going through their systems is quite interesting in terms of the shape of it. So on a daily basis, they have a lot of traffic at the very peak. So this is not an actual data graph. This is just showing the shape of the traffic. So at the very peak of the traffic, they're having about 100 million visits to their web application. The impact this has is that because this traffic starts around 8 o'clock and then goes to full, the maximum amount around 9 o'clock, it has a certain impact on how they do their releases. So you can see it tails off in the evening from about 5 p.m. onwards. So what this means is when they were looking at when is the best time to do a release, they chose a release window of around between 5 and 6 p.m. because they wanted to have some traffic going through the system so they can see the impact of their release, but they wanted to have not too much traffic, so if something did go wrong, it didn't cause a massive problem. And one of the impacts of this on the teams that were doing the release was that they'd do the release in the evening and it would go well, but they knew that the traffic was decreasing. And what they knew would happen the next day is when they'd come in at 8 o'clock, they would basically have an hour when they'd go from very little traffic to 100 million visits. And that was like a freight train approaching this new code. So things might have gone very well in the evening, but the real test was the next morning. So that was quite an interesting time to come in each day. The Scala Microservices place is a government organization. It's HMRC Digital. Have any of you done your taxes online in the last year? Yeah? Cool. It's been, the digital part of HMRC has been running for about 3 years old. So HMRC previously had its IT provided by a consortium of Capgemini, Accenture, and Fujitsu. And 3 years ago, HMRC realized that they could start doing some of their own stuff and started HMRC Digital. And Equal Experts has been involved since then. So it's had the benefit that all of the services that we've been building are effectively greenfield, though we're still having to integrate with some legacy systems. Over the last 3 years, it's grown from just one team to over 30 product teams, and these are spread across over 3 locations. And across all the product teams, they're all owning their own microservices, and they have the ability to deploy those microservices multiple times a day. It's a very, very simple deployment process. We have a web ops team that help make those deployments happen. In terms of their architecture, the detail of this picture is, you don't need to read it, but it's more, what's important is to communicate just how many types of microservices we have and the different nature of them. So around the edge, we have what effectively are the different front-end microservices that represent the different types of tax people might be interacting with HMRC over. So up here we have tax credit renewals, which has a peak towards the end of July. We have personal tax account, which was something that's been introduced fairly recently. So various other tax services that people will interact with HMRC through. Then in the center, we have infrastructural type services. So we have authorization. We also have transaction monitoring, so things that looks for fraud and does auditing. There's over, I think, around 300 microservices that make up this architecture. All the microservices are written in Scala, and if a microservice needs to persist data, then it does so using its own MongoDB. The microservices don't share databases. And all these microservices are hosted in Docker. The traffic for this culture is very different. It's very, very spiky across the year. And that's mainly driven by tax calendar events. So how many of you filed your self-assessment return online this year? Your hand up. Okay. And how many of you did it in January? Okay. How many of you did it like in the last 5 days of January? Right. Okay. A couple of people. So we see our traffic going up exponentially across the end of December in January to a peak day where we saw 11.5 million pages served. The other things that cause big spikes in our traffic are advertising. So I was out getting the donuts earlier and saw an advert that's related to this tweet by Martin Lewis. So there's a government tax break called marriage allowance, which has been running for the last probably year or 6 months to a year. And there's lots of buses going around all over the country now that are promoting the marriage allowance. And a couple of weeks ago, we have a Google Analytics dashboard in our office that tells us how many people are using our service per minute. And we noticed that we were seeing similar traffic to what we saw at the end of January when we have our peak. We thought, well, that can't be right. What is happening? You know, the end of January is past. People shouldn't be accessing us at the same kind of volume. And when we looked into a bit more, we realized that Martin Lewis has been talking either on the Money Program on ITV or some part of the media, which triggered a lot of traffic coming to our service. So those kind of things can suddenly cause a big spike in traffic hitting us. Okay, let's move on now to common patterns for success. So what are the things that are seen in both cultures that have helped them do continuous delivery better? So the fundamental practice that applies anywhere is starting with the best people you can hire. And I can't emphasize this enough. All of these practices that follow this are pretty much useless unless you can find really, really good people. And that's something that the Equal Expert specializes in. So they have a network of associates that all have been doing Agile and Lean for a while really well. So when Equal Experts goes into a client, they're bringing people in that know what they're talking about, that know what they're doing, and aren't having to learn all of this stuff. So that was best practice number 0. The first best practice that I saw in both places was helping people think about production the whole time, or in Homer's case, donuts. So it's important that instead of thinking about requirements and design, the typical kind of steps of software development, when you go through the steps in this way, people generally think about production towards the end. They don't think about production right from the inset. And this is a kind of pervasive way of working, unfortunately, in many IT organizations. What both cultures have realized is that you need to get people thinking about production the whole time, all the way through the process. So instead of the typical, effectively, waterfall approach, you need to think about how can you release something really small to production? How can you change production's behavior to be the way you want it? How can you make sure any changes you do to production are backward compatible in case you've got other services or different versions that are operating in parallel to what you're releasing? And finally, this is probably the one to start with. One of the most important things is teaching your developers that every commit they do, they need to think, is it safe to go to production today? Because in a continuous delivery environment, that's a real possibility that code change could be live within a few hours. So one of the problems that we had at the Dotnet monolith place was it was a very fast-growing organization. We went from, as I said, 2 product teams to about 8 within 2 years. And so we had lots of new people coming in that weren't very experienced in continuous delivery. They were either graduates or permanent people that hadn't worked in that kind of culture before. And we saw this in the pain that we started having with our weekly release process. It became harder and harder to achieve weekly releases. So one of the approaches we adopted was to set up a cross-functional virtual release team. So any team that had code changes that were present in the release, in the monolith that was going out that week, they would contribute 1 or 2 people, and either be a developer or a tester or both, to a virtual release team. The purpose of that release team was to be an integral part of the process of getting that release into production. So though the actual physical deployment of the code changes to production was done by a WebOps team, the WebOps team and the virtual release team worked together. They had a shared Skype channel, and they were talking to each other constantly over the release process to ensure that it went well. The release team would gather and start looking at the production logs before the release happened. So spend the first half an hour before the release went out just looking at what was production's behavior, a bit like taking the pulse of a patient, looking at their ECG, making sure that production is behaving as you expect it. Then see the release go out, and then look for any changes. And this technique was really powerful because over time, as different people in the team observe the release and start interpreting the logs, effectively the heartbeat of their application, it starts making them think more about how their changes when they go into production are going to affect that heartbeat. So it helps them start thinking about how their changes are going to impact production before they start coding, instead of right at the end when they do the release. At the Scala Microservices culture, we had a slightly different challenge. So their people that we brought in were all familiar with continuous delivery. It's something they're all experts in. So our challenge there was helping keep production at the forefront of people's minds the whole time. And the approach that we adopted to help with this is to make our Standups focused on production. So this is one of our Standups happening a few weeks ago. That's our Kanban board on the left. And so we had columns that the furthest right column was stuff that was in production, that was ready to release, and QA, et cetera, et cetera. So the way we run our Standups is that we always start from what's gone to production and work from right to left. And the first question that we always ask was, what did we deploy yesterday? You know, what is it that's gone out that we need to be thinking about, that we need to be checking our logs for, and need to be aware of in case any alerts come in? And then secondly, what are we planning on deploying today or tomorrow? So working the board from right to left, generally we're starting with the QA team who effectively manage the release process, understanding what they've done, what they're about to do, and then talking to the developers about what work they're going on that's approaching production. Second best practice that's seen in both teams is change the way people are thinking about testing. So typically in most organizations, including agile organizations, product delivery is done by the product owner defining some new change, a developer building it, a tester testing it, and then WebOps having to suffer the pain of deploying it. Particularly in the .Net monolith culture, one of the fundamental changes that helped them go from yearly releases to weekly releases was completely changing this thinking. Instead, helping the teams think about testing the whole way through. So right at the beginning of defining a new piece of behavior, a new change, having the team together with the product owner think about how they're going to test it. People were still doing their individual roles, but they were thinking about testing and doing testing all the way through. So the developers were making sure that they were writing unit tests and acceptance tests, ensuring that their code was testable. The QAs were also obviously continuing to testing, but changing the focus. The QAs were focusing now more on doing things like exploratory testing. And then working with the WebOps team to ensure that when stuff has gone out, we can understand its impact on production. So we've got the right metrics and logging in place. And we'll come on to logs and metrics a bit later. In fact, right now. So third best practice is looking at how do we know when something's gone wrong. So in IT, we've got an awful lot of data that tells us about what our system is doing. There's quite a big stack. Now, ideally, we'd like to cover everything. We'd like to be able to monitor all the things. So can you stick up your hand if your team does monitoring at the disk and network level? Anyone know what your disk's doing or CPU? Okay, how about service errors? How many people monitor how many errors their service is producing? Okay, How about performance? How many people are monitoring response times? Yeah. Business metrics. So how do you know if your service is actually, getting enough of a conversion in terms of users getting through the service? Okay, a few people. Social media, do any people get feedback from Twitter or anything like that? And people are doing big data, so using things like neural networks to look at small changes in a really big system. Now, so that's a big stack to cover, and it would cost a lot to set up monitoring, alerting off that whole thing. So it's important to think about where do you start. So what we'll focus on in this section is looking at what steps can we take to know when we've made a change, that change has caused a problem. So the typical steps that we would go through is when a change is introduced and causes a problem, we'd have something that detects that change, something that then alerts somebody to the fact that there's a problem and also displays what's gone wrong, gives people the opportunity to analyze it, and then ensures the right people know what's gone wrong and allows them to start responding to it. The challenge is that the longer you have from the problem being introduced to the time when someone can actually respond, so the amount of pain that your users are feeling, but also the amount of pain that the people having to respond are feeling. So the stress that is placed upon the web ops team or the developers that are having to do the response goes up significantly. One of the difficulties that we had at the .NET monolith place that we overcome was our process for detecting and displaying and problems was it relied on our web ops team. So we had lots of dashboards that told us what all of our systems were doing, but we were relying on people on our web ops team looking at those dashboards and noticing something changing. And what was even worse was the development team didn't have access to those dashboards. Those dashboards are actually in a locked room that only our operations team could get access to. So what would happen if something went wrong? The web ops team would notice it eventually. They would then have to do some investigation themselves, work out whether it was a problem that they needed to alert the development team to, and eventually they would get a developer involved. He would have to do some analysis himself and then come up with a fix. So one of the big things we did to help address this was pay a lot of money and introduce New Relic. How many people here use New Relic? Okay, is it awesome? Do you like it? It's very, very expensive, but it gives you a massive amount of information. We deployed it across all of our application servers, and it instantly connected the developers with production. They could see, second by second, what their production services were doing, and be able to respond much faster when there was a problem. They would be able to see straight away if there was a problem in production, and do the analysis and response themselves without having to rely on someone in web ops noticing and then telling them, then slowly getting them access to that information. So there's lots of different tools you can use in this process. For taking your logs, then it's possible to use Logstash and Elasticsearch. The .NET monolith place, we're using Papertrail across all of our application servers. HMRC Digital, we're using Logstash and Elasticsearch. For alerting, Sensor and PagerDuty are good tools to use. There's a plethora of tools you can use to do the display and analysis of what your production system is doing, such as Kibana and Grafana and Google Analytics, which is what we use at HMRC Digital, and New Relic, which was what was being used at the other place. So we'll now look at an instance where we had a problem at HMRC Digital and how these tools helped us. So at 11 a.m. one day in the last 6 months, a deployment happened like it normally does, several times a day, and that deployment introduced a defect into production. And people didn't know about it when it first went in, but 10 minutes later, that defect, which was causing quite a few people to be unhappy because they couldn't access the system, triggered an alert. That alert then went to several different teams. They then could see the details of the error on Kibana. They were then able to look up which microservices were throwing this error. They used a map that says these microservices are owned by these teams. They got in touch with those teams to get them to respond, and the teams could look in Kibana to see the detail of what was happening. So by 12:30 p.m., we had a fix determined and normal service was resumed. So having that ability to very quickly detect a problem, get the right people alerted to it, and have them be able to analyze it and respond to it as soon as possible, makes it much easier to make changes without too much worry about breaking stuff. Okay, let's now look at things that cause both these groups of people significant shared pains. What are the things that make continuous delivery difficult? So probably the most difficult thing when you're doing continuous delivery, particularly in a web environment, is doing a release so that your users don't notice. And there's several kind of good analogies to this. In this case, it's a bit like having a person, which is your production system, running on the treadmill, and you're wanting to make changes to this person without anyone noticing, the person noticing, any of their stats changing significantly. So this is quite a problem. It takes quite a lot of planning for both organizations. A good example of one of the considerations you need to make in a web environment is when you're making a change to something that is going to be accessed by different versions of your system across a period of time. So, example, if you're changing access to a cookie, for instance, when you make the change to the way the cookie access is done, then it's possible that when you roll out the new microservice, which has the new implementation, that will start working with cookies in one way, but there'll still be old versions of your system running that are accessing it in the previous way. So you need to define this change so that it is interoperable with both versions of your system, and then work out how you phase out the old method of accessing your cookie and phase in the new method. The second big pain point was having manual deployment steps. So I liken this to having each deployment that is effectively custom made, that you're giving web ops all the raw materials and then a big list of, if you stitch this thing together and this sleeve goes here and this sleeve goes there, that'll be fine. And don't worry, we've given you all the needle and thread. It's pretty automated. What could go wrong? What they really want is to be able to take something off the rack, stick it on production. At the HMRC Digital, one of the things that we did to address this was that our web ops team that actually were doing the releases, they made it a rule that they wouldn't do manual deployment steps, because what was happening was that the teams were saying, okay, we need these microservices to be deployed, but we also need this MongoDB script to be run, or we need this script to copy these files from here to there. And as the number of teams grew, and you can imagine these kind of requests were happening across 10 teams, 20 teams, 30 teams, so it made the cost of deployment higher and higher. So the rule was, if your service needs to run any custom steps, then you need to design that into your microservice itself. So your microservice does everything it needs. So when it's deployed, it takes care of those things. Now there's an anti-pattern to this, and that is that when you're trying to fully automate your deployment to production, it's very tempting to make the most complex process ever that automates every single thing. And that can take a long time to develop and can also be very, very costly. And it's a bit like if you've got a paperclip and you want to throw it across the room, you don't go and build a beluga to carry it across the room, you just make a paper airplane. So when you're implementing continuous delivery, it's important to iteratively put in the processes that automate the biggest points of pain in getting your releases to production. So next we'll look at the best practices that are specific to each culture, starting with the .NET team. So when we were growing and deploying to production each week, as the teams grew and started learning about how our production environment works, so we frequently hit problems where we'd be making changes and they would cause a production issue. And so we wanted to try and stop that from happening and help teams learn how to do things better. One of the best tools that we found useful in this situation was the 5 whys technique. So whenever we had a production instance, so something that affected a large number of users, we would, firstly, as the incident was evolving, we'd make sure we'd create a timeline to allow us to know exactly what happened and when. Then afterwards, we'd get all the people together that were involved in the incident. So all the people, meaning who was the first person that saw the incident? Was it someone in customer support? Was it someone in web ops? Who are the people that are involved in the deployment? Who are the people that tested it? Who are the people that wrote the code? Who was the product owner that specified the change? Get all those people together in a room, walk them through the timeline of what happened so everyone's got the same context. And then decide at what point we're going to ask, why did this happen? So we'll look through our timeline and say, okay, this was a real concern to us. Let's understand, why did this event happen? And what could we do to stop it happening next time? What process change could we make? And keep asking why 5 times. And that was a very valuable process because as you're asking why, so people are learning different things, not just about production, but also about what different people do across the company. So it might be that the first people that saw the bug was someone in customer support. And so the developer that introduced the change and the customer support person that noticed it, they'll start learning about what how each other's role impact each other. It's also useful if you're doing this in a large group to perhaps split up the people present and have them choose different entry points to explore. That's just an example of the kind of matrix that you might end up with at the end of that. The second problem that we had at the monolith environment was understanding what we should be regression testing. So we had a monolithic release that had changes from possibly 4 teams, and we spent a period of the time trying to run lots of different tests over that release. And this is a bit alike or akin to doing spot the difference. So we have something in production, we have a release that we're hoping to put into production. What's changed? What are the areas of risk between these 2 versions? And it was very, very difficult trying to collate all of the changes into one place and understand the impact. And that was because the information about these 2 changes was in 2 different places. So we had our source control system that said physically what bits of code have changed, and then we have our project management tool that says why have these changes been done. So what we did was we wrote a system that combined all the information. So it used APIs from both systems to automatically generate a release note that looked at the version of code that was in production, the version of code that we're going to release, go off to our Agile project management tool, and by parsing the code commit comments for the version that we're releasing, it could then work out, okay, which are the features, stories, and defects that are present in this release, what state are they in, who did them, what area of code are they in, are some of these changes still being worked on, because we were doing commits into trunk with feature toggling. And that tool was invaluable. So if you have a monolith that you're deploying regularly, I highly recommend you set up this kind of system. The slides will be available afterwards, by the way, and I'm going through this quite quickly now. Okay, so the Scala Microservices culture, what was their best practices? So it's really important, I think, when we had going through for a microservice type environment, that teams own what they're building. And by ownership, what we mean is, to quote Werner Vogel from Amazon, you build it, you run it. If you're creating a microservice, WebOps will help you get it into production, but it's up to you, the team, to monitor it, to understand when something goes wrong, what they should do to fix it, and also to know when something goes wrong. And that's something that, if a team is new to continuous delivery, it can be quite hard for them to get their heads around. The other implication of owning your own microservice is preferring service over library dependencies. So what we've found is that if you have behavior that's wrapped up in a library, and then that library is shared by lots of different microservices, so it can be quite hard to introduce improvements or bug fixes into that library. It's much better to encapsulate behavior into a microservice itself, and so if you need to make a change to that behavior, then you just need to deploy that microservice and other services, and you will just pick it up. The other thing we've learned that has really helped us is ensuring that our APIs or microservices are backward compatible, which means that you're following the principle of least surprise. So what happened in the early days of HMRC Digital evolving was that the different teams were working on their own microservices, and some would rely on each other. And there was one team might be testing one version of their microservice, and it was using some other microservice that another team owned. And Team A would notice that Team B had suddenly changed the version, had released a new version into dev or QA of this microservice that they were dependent on. and that would cause things to break. And so, well, we can't keep testing if you're changing stuff. So the teams then thought, well, the best idea is that if each team can have their own environment where they can have the microservices that are running in production and then deploy their own ones and test it there. And that mean that they wouldn't be affected by the changes that other teams are making. Unfortunately, our WebOps team said, no, this is a crazy idea. The principle that we need to follow is we'll have one environment, one dev environment, one QA environment, one staging environment that everyone shares. Because if everyone is releasing all of their microservices into these environments and testing together, but making sure that what they're deploying is backward compatible, then the way we're working is most like what happens in production. Because in production, you don't know what version of microservice someone's going to deploy at any time. Let's go back a step. There's one other thing I was going to say on that. No, pass. Okay, we'll move on. So if you want more information about some of these best practices, then I highly recommend this book, Build Quality In. It's written by some of the organisers here. Value stream mapping is also a good practice to use to look at how you can improve different aspects of your delivery process and try and improve your continuous delivery. And that's described quite a lot in this book. And this is the Bible of continuous delivery. It's well worth having a look at. Finally, who's read Release It here? Has anyone read Release It? Okay, so this I think is the best book I've ever read on software development, and I'll highly encourage you to read it and get everyone on your team to read it. Okay, thanks for listening. I think we got how much time for questions?
Yeah, plenty of time for questions.
Anyone have a question? Wow.
I'll ask a question. So, hello. So you were talking about spotting a problem in production within 10 minutes. Yep. And then fixing it within an hour and a half. So for me and for my business stakeholders, that would not be acceptable. Because for some context, I work on a team that does the sign-in for the whole of Tesco. So 10 minutes for us is hundreds of thousands of pounds of lost revenue. So what kind of techniques do you think we could use to kind of speed that up? What kind of things should we be doing to kind of get that hour and a half down to something quicker?
What would be acceptable in your environment, do you think?
For the business stakeholders, it'd probably be 15 minutes tops.
Okay, so in this process, it would have been possible to have fixed the problem here within 10 minutes by rolling back straight away. Okay. And the fix that we actually did up here, at 12:30 was to roll back, but the period of time that lapsed was spent analysing, trying to understand what the actual problem is, where were the, which microservices were at fault here. So what some places do is their monitoring is so sophisticated that if they detect a problem, and the systems can pin down which microservice it is, they will just roll back to the previous version of that microservice.
Yeah, and I mean, in terms of that detection, was that done by the team themselves, or?
No, this was this would have been like a certain number of errors, or an error threshold being exceeded, and that error threshold would have then triggered an alert through Sensu that would have then triggered a PagerDuty email. So you could have probably set up Sensu so that when the error threshold was triggered, you might have been able to then kick in some other automated process, such as an automated rollback. The difficulty we had in this particular scenario was that the microservice that started erroring wasn't the one that had been released. It was a different one. And that's what made this kind of situation slightly more complicated. That's why it took us an hour and a half to actually respond and roll back the correct microservice.
Great, okay. Thanks.
What other questions are there? One at the back.
So I'm kind of new to some of the concepts around microservices, and I was at a presentation or a meetup of this group maybe about 2-3 months ago. But I thought one of the major advantage, I kind of got the advantage of microservices in a sort of a dev environment, so we can all have our own dev. We've got a full environment there in which we can work on and so forth. But when you go into production with it, is it fair to say that the problem you have here is in this particular slide is contained to just that, or one or two microservices, and the rest of the system was all good? Or did this error, in effect, disable the entire site?
No, in this case, it didn't disable the entire site.
And is that generally true then?
No, it's not generally true. Okay. So it really depends on kind of which microservice is causing the problem. So if we go back to picture the architecture. There. This one. So any one of these things around the boundary, they have 2 or 3 microservices each. If any of one of those caused a problem, it would just be limited to that interface, that point of contact. If it was something in the center, like our authorization microservice, then that would have the potential to impact all of the things that depended on it.
There were people viewing the site, for example, as opposed to just using it, saving and stuff. Okay.
Does that? Yep. Okay.
It's application specific.
Yeah, it depends on which microservice is having a problem. So.
And what are the purple ones?
These here.
Yeah.
They are different APIs. Okay. The purpose of this diagram was more just to illustrate, the kind of different levels and the arrangement. What other questions are there?
So do you have different approach when releasing a core service against? Thanks. Do you have a different approach when releasing a core service against releasing an independent service at the end?
No, we don't.
But the risk is quite different. Significantly different and bigger.
Well, I think, there could be some more significant risk. The practices that we employ there around each microservice is to make sure that we're going through significant amounts of testing. And also, we're making sure that the changes that we're releasing are fairly small. So applying the kind of principles of small amount of change and lots of testing to at any level, it ensures that reduces the risk that we're going to put a problem into production. We also do a lot of monitoring when something goes in. So if something does go wrong, the team are actually physically watching what's happening, so we can roll back very quickly when something does go in. So the team that I happen to work with, whenever they do a release, they're looking at the logs and doing tests on production themselves, and in communication with the web ops team, so that if something has gone wrong, they can make a decision to roll back. So typically we can roll back something within a couple of minutes.
In this respect, how many environments you have in your pipeline before reaching production?
We have a local environment where people are writing the code and testing on their own machines. We'll have a development environment, a QA environment, staging environment, and then production.
So full pipeline of environments,
yeah.
Actually. Okay, thanks.
Okay, so another question.
So to help manage risk earlier in the process, did you employ anything around contract tests between the different systems and the APIs you had in place?
That was something that was discussed, and a few people wanted to do that. That wasn't something we actually did, though. We by having all the teams use the same environments for doing their testing and development. That means if people do introduce a breaking change, people know about it really quickly. And so just the sharing of the environments was a good way of helping people realize if they've introduced a breaking change. Does that answer your question?
Yeah, kind of. Did that also lead to certain environments being quite unstable? If you ended up with lots of change that hadn't reached production that other people would then expect to work
it caused a bit
against?
of pain when people were getting used to this idea, and when people were getting used to this idea of everyone sharing and caring, people were thinking contract tests would have been useful, and there probably is still some value in that. One of the things about the old caring and sharing and making your things back compatible, one of the implications of that is that if you are wanting to introduce a breaking change, you need to plan that really well. So we do change our APIs and change the kind of core microservices other things depend on. But in order to introduce a breaking change, we need to communicate out to all of the 30+ teams that are affected, tell them why we're making the change, what it means to them, what they need to do to prepare for that. They need to then effectively update their microservices in preparation. So there's like a multi-week process to get significant breaking changes out. But it means that people can keep working in all of the environments and not be impacted.
Okay. What sort of visibility do the core teams have of all their different system users?
Can you explain what you mean by visibility?
If you're creating an application, that central hub, that's then going to be used by potentially all of those external microservices, do those central teams know every single microservice that's going to be using their system?
Not always, no. We have had cases where teams start using some of the things we built without us knowing about it, which is, a bit frustrating. I think generally when we've got a new service, we will try and promote it and talk to as many different teams that we think would be of interest to it as possible, and also have some kind of onboarding process so that the teams can learn about how to use our API and work with us to test it. Any other questions? There's one at the front.
So how many source code repositories do you have? So does each service live in its own source code repository, or is there one big where all the services are in?
We have so for HMRC Digital, we have some of our code in the open on GitHub, and that's just in one HMRC repository. And we also then have a private GitHub repository as well, which is again just one. Alan, can you add anything to that?
I think you're asking about mono repos. It's not a mono repo.
Thanks. Any other questions? No? Okay.
Thank you
very
very much.
Thanks.